This is Physical Science with Mrs. Lewis. Welcome back from part 1 of chapter 25. This is the second and last video of section 1. So just a reminder in case you didn't watch it the whole way through, plate tectonics theory is what we're talking about. And we've talked about convergent plate boundaries, and we had just started discussing divergent plate boundaries. A mid-ocean ridge is one example of a divergent plate boundary. Divergent plate boundaries exist as continental, such as the East African Rift. We have a third type of plate boundary, and it's called a transform plate boundary. Some plate boundaries have faults where mostly horizontal movement is taking place. Remember, horizontal goes this way. Plates slide horizontally past each other along a transform boundary. So if these two things were here, let's say 2 loaves of bread or 2 erasers, and if I pulled one towards me, at the same time pushing the other one away from me, that would be a transform boundary. Now, it's very important to understand that for plates in motion, thermal energy from Earth's interior drives plate motion in a process called convection. As plates move and interact along plate boundaries, forces like slab pull, ridge pull, and friction also contribute to the process. So a little bit more about convection, because it is the fuel, it is the engine, it is what drives everything about plate tectonics. Thermal energy produced during radioactive decay in Earth's core is transferred up into the mantle. As the mantle gets hotter, buoyant mantle material rises to the base of the crust. It cools and then sinks back down, creating a convection current that makes plates move. So up until now, if you enjoyed earth science back in middle school, this is all going to be very familiar to you. But some new things you may not have heard of: slab pull, ridge push, and friction. So let's talk about what they are, because you need to know them. Slab pull is a force that pulls plates down along a subduction zone. Ridge push forces plates apart along a mid-ocean ridge. And friction between plates and the mantle also helps move those plates. Whether you are choosing to use the note packet or you're choosing to go ahead and write everything out in your notebook, I want you to take a section of your notes and I want you to write it down exactly how it's being presented to you.
There are 3 basic types of plate boundaries, right? We have our convergent, our divergent, and lastly, our transform. Now, in terms of plate movement, the names really do speak for themselves. In convergent, in all cases, we will have 2 plates, right, represented by these 2 rectangles. So those are the basic plate movements. If you know the word converge, you know that means to come together, and if you know the word diverge, you know that means to move apart. And then, of course, transform, if you want to think of like a graphical transformation, then sort of moving side by side makes sense. So the names are pretty self-explanatory. But then we can have a whole bunch of different outcomes at each one, which I'll just sort of outline in this video.
And outcomes will also be part of your test.
At convergent plate boundaries, we can have a few things. One, if there is a continental-continental collision, so we'll call that C, right? Continental. 2 plates that are both continental crust collide. Then we're going to have the formation of mountains, right? Because if you think of it, it's sort of like 2 plates being pushed together. What's going to happen? They're going to, under the stress, they're going to fold upwards like that. So a continental and a continental results in mountains. A continental and an oceanic, CO, what's going to happen is called the subduction zone. So subduction is simply when the more dense plate, which is the oceanic crust, goes beneath the continental crust and actually dips into the mantle. So it looks something like this. That's our continental and that's our oceanic. you're going to see the oceanic actually move underneath the continental crust and then go into the mantle below, and eventually, sometimes almost at the core boundary, the mantle core boundary, the plate will melt and we'll get a magma plume that rises up and causes little volcanoes up here. So you get volcanoes, you can get subduction, which can lead to volcanoes on the continents, and lastly we can have an Oceanic, which you hear about a lot less, but it's a similar case to the Oceanic continental, right? The older oceanic crust, if you have two plates, the one that's older is going to end up subducting beneath the other one because it's more dense. Usually it's going to be the older one that's more dense, colder and denser, and therefore it will subduct beneath the younger one, and you'll get, instead of volcanoes on islands, you'll actually get little volcanic island arcs. Right, because you're going to have the formation of volcanoes just in the middle of the ocean. So if they do rise up above the surface, these will appear to be volcanic islands. So that's convergent plate boundaries. Then we have divergent, and the only really one we're concerned about here is what happens in the oceans, because we actually don't have any divergent plate boundaries within continents. So the big thing about divergent plate boundaries is we are going to have mid-ocean ridges. These are very interesting. Might make another video on them.
Otherwise known as MOR.
But, just imagine these two plates pulling apart, and then basically, I guess I can draw a bigger picture down here. Two plates pulling apart, and then basically magma from beneath, right? Just pretend this whole thing down here. This is all magma in the mantle. So it's actually going to rise up and fill this space. And what you're going to have is new rock that solidifies, right? Igneous rock coming up. It cools once it reaches the water. And you're going to have the formation of this little, over time it becomes taller and taller and wider as more and more solidified magma, igneous rock accumulates. And you're going to have the formation of a ridge that stretches across the entire divergent plate boundary. And then gently sloping downwards until it reaches the normal ocean floor. So that's what divergent plate boundaries are really notable for. And then finally, transform, also sometimes called conservative plate boundaries because no continent or no crust is created or destroyed. That's right, divergent are also sometimes called constructive because you get the formation of new rock, which becomes part of the crust here. And convergent, or specifically subduction ones, are considered destructive because you have a plate subducting into the mantle and melting eventually. But transform are also called conservative because we don't really get any creation or destruction of any crust. When they're just scraping past each other, the big thing you have to know is just that we're going to have earthquakes, right? And make no mistake, earthquakes can occur at all of these, but some of the most notable earthquakes you're going to find are at transform plate boundaries. And there's really nothing else too defining about these plate boundaries. You'll have ones like in California that, create very notable earthquakes, but not a whole lot else to say about transform plate boundaries.
So since he brought up California, let's talk about that. So the whole time I was growing up and in my science classes, they were saying eventually California is going to pull apart from the continental mass known as the United States and it's going to break away. Well, that's not exactly true. California is a major transform boundary plate. So it's not going to convert, it's not going to diverge. It's not going to break apart and pull apart like you would pull apart an Oreo cookie to get to the best part, the inside, right? And it's not going to converge together like a sandwich, two pieces of bread pushing in on the filling, the hamburger, the lettuce, the tomato, all that good stuff. It's actually going to be sliding off of the continental United States. So here you go. That's all you have for section 1.